Okay, we can start. So good afternoon, everyone from Brussels, or good morning, or even good evening, depending on the time zone you are currently based. And my name is Vasilis Rizos. I'm Head of Sustainable Resources and Circular Economy at CEPS, and I would like to welcome you at our event on chemical recycling, what is the state of play globally. Now, as you may know, chemical recycling is emerging in the discussions around plastic waste generation globally as one of the potential solutions for addressing this challenge. Now, there is a growing interest or even momentum, I would say, around this topic, and this is made very much evident from the various announcements for joint business collaboration or developments of new chemical recycling plants globally, but also from the increasing rate of academic publications on the topic, which shows that there is significant research interest as well. Now, in July, we organized the first event on this topic, which really focused more on the EU policy context, and there are several regulatory developments ongoing, which we discussed in more detail in July. And today we would like to expand a little bit the focus of discussion and really look into the landscape of different chemical recycling technologies that are applied globally. And specifically, we would like to discuss the challenges and opportunities, of course, linked to these different technologies, the existing market, economic, and even regulatory barriers, but also potential trade-offs and even risks with further link to further upscaling these technologies. Now, in order to have a discussion around this topic, we gathered today representatives from companies that invest in Europe and elsewhere on different circular chemical recycling processes, but also representatives from academia and NGOs in order to have a debate. Yeah, I can see some comments that you cannot hear me very well. I mean, is everything okay, Isabel? Can you hear me? Okay.
We can hear very well.
You can hear very well. Okay, good. Okay, good. So just a few words regarding the structure of the event. So we will kick off with Ropin Lee, who is Head of Technology Assessment Division at the Institute of Energy Process Engineering at Technische Universität Akademie Freiburg. Sorry for my German pronunciation here. So Ropin will set the scene for discussion today, and she will bring forward insights from the research that her team is doing on different chemical recycling processes. Then we will move on and we'll be having three representatives from companies that implement different circular chemical recycling processes. So we will start with Oti Teras, who is Head of Technology Commercialization at Neste Corporation. Neste is a producer of renewable fuels, And on chemical recycling, they specifically focus on the purification and upgrading of liquefied waste plastic. So we will be hearing about their processes and joint ventures in chemical recycling. We will then continue with Adrian Da Costa, who's Global Business Development Director, Advanced Recycling and Circular Polymers at ExxonMobil. ExxonMobil is investing on pyrolysis processes in Europe, but also in the USA, and is also participating in some joint ventures. So he will provide his perspectives on this topic as well. So then we will conclude, let's say, this line of speakers from companies with Mattia Komoto, who is Circular Economy and Sustainability Project Manager at Aquafil. Aquafil is a producer of nylon yarns for carpeting and apparel, and is implementing a technology that fits within the group of depolymerization chemical recycling technology. So it will be interesting to hear his perspectives as well. And finally, we will conclude with Yannick Vach, who is Climate, Energy and Air Pollution Coordinator of Zero Waste Europe. Now, Zero Waste is an NGO following closely the policy debate around plastic waste, but not only, of course. And Yannick was also present at our event in July, and we will welcome his comments on the previous presentations, but also his views in general on chemical recycling. Now, all panelists will have around 7 to 10 minutes for an initial contribution, and that should give us enough time, hopefully, for discussion. So I would like to encourage all of you to use the Q&A function of Zoom, which perhaps you are already familiar with, since in these digital COVID times. Feel free to bring your questions. Please mention the name of your organization, your affiliation. It will really help bring the perspectives in the discussion. Finally, I should say that some of you, of course, are following this event through YouTube and some of you through Zoom, so we have different routes of communication today. And with no further delay, I think I can first give the floor to Robin Lee, who is joining us from Singapore, I understand, so a completely different time zone. So Robin, thanks a lot for taking the time late in the day to speak with us. I understand that you are involved on research on different pyrolysis and gasification processes, but you are also very close to the market commercialization of this technology. So I guess you will have a lot to say about your work in these areas.
Thank you. Thank you, Vasilis. Thank you, Seth, for giving me the opportunity today to share some of our work in chemical recycling. Let me just share my screen because I have prepared a small presentation, which I think would be helpful to guide us along the talk today. Okay, a quick indication if you are seeing my screen well, vocally. Is it okay? Yep.
Yes.
I assume yes. Okay, great. So my name is Robin. As Vasilis says, I'm dialing in today from Singapore. I'm actually from the Institute of Energy Process Engineering and Chemical Engineering, IEC for short, from the University of Freiberg in Germany. So this is a very exciting topic for us because our institute is not only involved in technology development of pyrolysis and gasification technologies, we are also involved in the integrated assessment of such technologies, looking at them from the social, technological, economical, ecological, and political perspective. So when we talk about chemical recycling, as all of you here today, I'm sure are aware, a lot of organizations have came up with what they understood as the definition of chemical recycling. And this understanding of chemical recycling differs between organizations sometimes and also between countries. Today, there is still no conclusive technical or legal definition what is chemical recycling, also known as advanced or feedstock recycling in some countries. But we do identify that there are some common characteristics for all these different definitions. It is about changing chemical structure of waste, predominantly plastic waste, via chemical agents or thermochemical processes to produce basic chemicals or feedstock for the chemical industry. And this encompasses a wide range of conversion technologies and recycling pathways. Generally, energy recovery is excluded, and to a large extent, fuel production, but not really everywhere. For example, in the USA, the production of fuel is still considered chemical recycling if it's produced from waste. A lot of times, the definition of what constitute as chemical recycling depends on the production and its utilization and not the technology per se. So now we come to the Europe context. When we talk about European waste hierarchy, we are talking about reducing and prevention, and then about reuse and recycling before recovery, which is very often thermal recovery, as in the case of waste incineration, and then landfilling for disposal. Where does chemical recycling fit into this picture? As you can see, what we have drawn here, it basically fits into the recycling block to complement mechanical recycling for waste. I'm sorry, are you seeing this? I just put that down, sorry. So for waste, which is, we would say generally not suitable for mechanical recycling. Very often, when we talk about chemical recycling or recycling in general, two characteristics are of, I would say, the most important consideration. One part is how pure is the feedstock versus what is the quantity of the waste feedstock. Generally, those feedstock with high purity, waste of high purity, we are talking like PET, for example, the quantity is not so much. And as we move along, as they get more impure, more mixed, more contaminated and dirty, what we get is the quantity increases when we think about municipal solid waste, for example. So this is just an example of, based on the example of plastic to plastic. What happens in the case of, sorry about that. What happens in the linear economy is following extraction, we go through refining and chemical production, producing the polymers, and then going on finally to the plastics. And what happens after utilization is it could go through a whole range of different recycling routes where they are recirculated back into the chemical production chain at different areas. And today, for the rest of the slides, I really want to focus on this too, pyrolysis and gasification, for the rest of our discussion. What are the technological advantages and challenges when we talk about pyrolysis and gasification? For one, looking at pyrolysis, what we have noticed based on the market development is that it's suitable for a range of plastic waste. And what is really charming about pyrolysis is the possibility for the products to be integrated in existing petrochemical sites, for example, as a naphtha substitute for production. And also, the scale of production is not that big. So we are talking very often a modular kind of production, and this allows it to be very attractive for decentralized production. And the pyrolysis oil, which is produced in smaller quantity, can be channeled altogether to a centralized position or location, such as at a chemical production site for centralized utilization. So that's the charm of pyrolysis. But on the downside, what we have noticed based on the screening of pyrolysis technology providers on the market is that a lot of the technologies are suitable mainly only for the mixed polyolefins. We are talking PP and PE. And very often the oil quality is challenging. Oil quality, pyrolysis oil contains a wide range of different components. And it is quite challenging to get this to match the specification of cracker. A naphtha cracker, for example, which is like this very sensitive machine. So very often, in order to make sure that the oil quality could fit specifications of a cracker, you have to make sure that the waste which is going in is relatively pure. So that's one restriction for pyrolysis for a lot of the technologies out in the market. Scaling up tends to be also very challenging, and treatment of byproducts is also an issue which is not very often addressed openly. Some examples of pyrolysis projects out in the world today. Agilyx have a plant in the USA focusing on polystyrene waste to monomers, and they're operating at 10 tons per day. Plastic Energy have 2 plants in Spain, for example. They are operating at 15 tons per day. We have the CTC technology from Carbolit in Germany, and they are kind of unique because they are looking at municipal solid waste, so a mixed range of feedstock, which is not just plastic, and operating at 12 tons per day to pyrolysis oil. And what's interesting is Brightmark Energy in USA, which has currently a plant which is undergoing construction and going into commissioning. That's on the larger scale, going at 300 tons per day. So as a contrast, let's look at gasification. Compared to pyrolysis, gasification is on a much larger scale. And It also has a wider feedstock flexibility because it operates at a much higher temperature and generally at pressure, which allows it to break down the feedstocks into synthesis gas components into molecules. And the advantage of gasification is that the synthesis gas, which is a mixture of CO and H2, it can be channeled on for chemical synthesis, a wide range of synthesis possibility. We are talking methanol synthesis, ammonia synthesis, etc. And through all these routes, you can come up to a wide range of products. And this whole process enables the integration of renewable hydrogen. So ultimately, in the future, where we have so much renewable electricity on the market that we do not know what to do with them, we can integrate them into gasification process to go for really CO2 neutral chemical production. So that's the chart. But challenges are definitely there. For one thing, we're operating at such high temperature and generally high pressure conditions, you're going to face carbon losses along the processes. And the technologies which are being deployed on the market right now, very often they are targeting higher calorific waste of about, I would say, let's say we are talking 20 megajoule and above. So if we look at municipal solid waste, which is generally about 12 megajoule, 14 megajoules, yeah, this is the question. If such technology, what needs to be done to prepare the feedstock to make sure it can accept this kind of lower calorific waste? Gasification has complex process chain. And it is on the larger scale, it is more complex than pyrolysis, and that translates into a higher capital investment cost. And the question is, if you have a larger scale plant, where is all the feedstock supposed to come from? I mean, even the pyrolysis providers on the market are noticing now, right, that feedstock is really the bottleneck right now. Some examples of pyrolysis, gasification projects which are out in the world right now. I'm sure many of you have heard about the Ibarra Uva project with Showa. This is a plant, and I sent a typo on my side. Yes, this plant has been in operation since 2003, not 2013. Sorry about that. And it's actually processing post-consumer plastic waste, focusing on hydrogen production for subsequent ammonia synthesis, so for fertilizer. And next example is Anachem, also very interesting. It has a biofuel plant in Canada, in Edmonton, in operation since 2014 for methanol production. And now in the last years, they have switched to ethanol because it makes more of a business case. And Anachem has announced a couple of projects in Netherlands, Spain, Canada, China, etc. Thermochem recovery. I'm sure a lot of you have heard about this big project they are pushing in Sierra biofuel plant in USA. Construction is supposed to be completed in this year already, and so they must be going into commissioning, and they are targeting municipal solid waste for FT Syncrude, so Fischer-Tropsch products. And last but not least, we have Innertech. Another interesting technology is plasma gasification combined with fixed bed, so according to them, looking at a smaller scale because this actually came more from the hazardous waste gasification side. So the global state of play for pyrolysis and gasification today. If we look at pyrolysis, generally what we are observing is that the technologies have lower feedstock flexibility, but there's a large number of technology providers on the market, more than 46 and still counting. And the average reactor size, we are looking at about 12 ton, and scale-up target has been announced all over, looking at probably around 54 ton per day. The focus for commercial deployment that we are observing right now is about 20 to 100,000 tons per year capacity. There are challenges that, as I already mentioned in the previous slide, is really quality of the feedstock versus oil quality. So attention is moving now also more towards upgrading of pyrolysis oil so that larger quantities can eventually be fed into the naphtha feedstock. Cracker, sorry. Gasification. In contrast to pyrolysis, we are looking at greater feedstock flexibility for gasification, but there's fewer technologies on the market compared to pyrolysis. Average reactor size is 5 times more than the pyrolysis reactor. And of course, the scale up, we are looking also at a much larger scale. It's a lot, also a couple of projects in planning or undergoing commissioning, and a lot of work is ongoing in gasification, targeting increased feedstock flexibility, and also to increase efficiency and scale. If you look at gasification, gasification is not something new. Gasification has been around for a long time for coal gasification. That development actually arose from Germany in the 1930s and 40s already. And on the other hand, for hazardous waste gasification. And coal gasification focus on homogeneous feedstock. So the challenge is, how do I shift this industrial technology focusing on homogeneous feedstock to something very heterogeneous? That's that challenge. In terms of hazardous waste gasification, it's on a smaller scale. Then the question is, how do I upscale that? So feedstock availability is a challenge for gasification technology because we are looking at plants which are 100, 300 to 500,000 tons per year. So you need to have a very stable, secure, available feedstock supply in order to ensure that the gasification plant is operating stably. The question is also business case. With such a high capex, how can gasification meet a business case against pyrolysis, for example, and also against waste incineration? So coming finally to my last slide on some of the trends and developments which we are observing. Chemical recycling. The role is to complement, not to compete with mechanical recycling. The focus we are saying that the market is placing on, or increasingly focused on, and also the policymaker is moving away from the pure plastic streams to mix and challenging wastes. And that includes also carbon fiber, glass fiber materials, the composite, sewage sludge, automotive shredders, etc. There's also a lot of interest nowadays in how there could be intersectoral synergy, not only focusing on circularity, which has been what chemical recycling has been generally about, but also how it could eventually contribute to decarbonizing industry and mobility. Cost reduction, increasing the scale of impact through upscaling and site integration possibilities is, of course, a huge market interest. But there's very uncertain regulatory developments going on, which are hindering investments in this direction. It is unclear what is counted as recycling quota, whether transportation from fuel from waste is counted as recycling, and where is the role of chemical recycling compared to waste incineration. Just to share some examples of how regulations could have a supporting impact. US carbon capture credits has really incentivized activities in this direction. Netherlands, with the introduction of new carbon tax for the industry, including waste incineration, has really also been a huge driver for new projects in this direction. And government subsidies, having a guaranteed gate fee for the waste for chemical recycling and a price premium for CR products, has been what has really supported the continual production of the Japan plant. And lastly, just the last point is, we are hearing a lot of discussion about CR technologies, but it seems that there is a lack of transparent information or even any information on the technologies to allow policymakers and decision makers to really evaluate what could be its role in the waste hierarchy. So we are aware that the EU JRC is looking at the LCA study for CR technologies. Our institute ourselves, we are also currently working on a project funded by the European Climate Foundation to develop recommendations for guidelines for LCA and TEA, so techno-economic evaluation, specifically for CR technologies. So all these developments are something which is happening right now in this very dynamic field and very exciting field. And I'm looking forward to hearing from the other speakers today and also to the discussion with you guys later on. Thank you.
Thank you, Robin. Yeah, I mean, it was a bit, you went a bit ahead of the time, but it was so interesting.
Sorry.
I didn't want to interrupt. And I think you said the scene very well. Now, there are a number of questions in the chat box. Some of them are of technical nature. Maybe you can see which ones you can answer while the other speakers are presenting. Now, I have a lot of questions myself, so I keep most of them for the discussion later, but just a quick follow-up question. I found very interesting your second slide presenting this landscape of different definitions and interpretations. And for me, this immediately brings a link with the circular economy concept in general, which is used, which is often an umbrella concept that is used to describe a lot of different things. Now, for some people, that brings a variety of other issues, different interpretations, different at the member state level, at the policy level, at the company level. So, or a confusion, if I can put it in more simple terms. So I was wondering whether you see similar risk for chemical recycling as well, and whether, what do you think is the way forward? I mean, should we continue keeping this umbrella kind of terminology for all of these different processes, or do you think that there could be a different way forward that could perhaps provide a different level of clarity? Yeah, whatever thoughts you might have on this. Yeah.
Yeah, I think the definition is from what I'm aware, also from the discussion with Yannick, right, on the definition of recycling generally looking from the policymaker perspective, they want to try to have a definition which is more encompassing, also to allow for developments in that particular area. If I'm looking at a technology perspective, then it's very process driven, but I'm not sure how much that is useful for the civic society, which is maybe interested in other aspects. So there's no easy answer to the question of how do you define it, whether umbrella definition is better or more specific definition is better. But this is something which is an ongoing discussion thing, and maybe Yannick will have some more perspective on that, and maybe he could address it there. I'm going to bounce it in this direction.
Okay, good. Okay, many thanks, and we will get back to the recycling definition, be sure for about this later. So yep. Okay, let's move to the next speaker. So now we have with us Oti Teras. Yeah, maybe Oti, thank you for your time, for being with us today. Neste has announced a lot of different partnerships with companies, and you have adopted and understand this value chain approach. So yeah, what can you tell us about this these processes and the value chain approach, or any any thoughts about your technology and challenges you may face?
Okay, muted by the admin. Thank you. All right, so first of all, let me introduce myself. So Oti Teras is the name, and I'm head of technology commercialization for chemical recycling technologies at Neste. And for those of you who don't know Neste, we are a Finnish oil refining company. During the past, let's say 15 years or so, we have made a grand transformation from being a regional oil refiner to focus on renewables. Currently, over 90% of our profit comes from renewables. So you could say that we're not in the business of oil refining, but rather in the business of fighting climate change. And currently, we are the leading provider of renewable road transport fuel, sustainable aviation fuel, as well as a provider of 100% renewable hydrocarbons to the petrochemical industry. Our focus has been on low quality waste and residue feedstocks, let's say, such as used cooking oil, and to upgrade those to high quality drop-in products. And with chemical recycling of waste plastic, we are leveraging that know-how in processing challenging raw materials. Neste has set a target for 2030. We want to be able to process over 1 million tons per year of waste plastic, to chemically recycle it back to the petrochemical feedstocks and to the circular economy. Now, as very well depicted by Ropin, chemical recycling is a family of different kinds of technologies. Our focus is specifically on the liquefaction route, where the potential technologies include pyrolysis, hydrothermal liquefaction, for example. So we like to talk about liquefaction as a general term instead of pyrolysis, because we see that there are also other technologies out there that transform the waste plastic into a liquid that can then be used to replace crude oil or virgin fossil raw materials in refining and the downstream processes. Now, Neste's focus is on the waste plastic streams that have low or no value in mechanical recycling, and today end up in incineration and landfill. And with such mixed and contaminated streams, you get a number of detrimental impurities, and also the chemical composition of the oil is not optimal for steam cracking or for the plastics production. So as we see it, in order to really truly scale up this chemical recycling industry, at least on the liquefaction route, upgrading and refining is a must-have part of the value chain. And of course, seeing that Neste is an expert in refining these challenging feedstocks, this is what we see as the most natural role for ourselves in the value chain. Already last year, we successfully started upgrading liquefied waste plastic in industrial scale at our refinery, and the work continues. But in addition to the internal work, we also collaborate with partners along the value chain. For example, we have partnered with Ravago, who are an expert in mechanical recycling, and we aim to build together capacity in chemical recycling. A couple weeks back, we announced our aim to form a joint venture company with Ravago to build a site, a chemical recycling site in the Netherlands. And the technology that we have chosen for that site comes from Altera Energy, who is one of our liquefaction technology partners. So we have been partnering across the value chain quite actively. And yet, you know, while we make progress in leaps and bounds, it is clear that the industry is not quite there yet. The technologies certainly still need development to make sure that we reach the continuity and reliability and robustness of technologies that is expected of industrial operations. We also need development of value chains, and especially to close the loop between waste management and refining operations of petrochemical industry. I mean, waste management in the linear economy is as far from oil refining as possible. But to really build the circular economy, we need to close the loop and bridge the gap between these two industries. Of course, we also need the technologies then in between. Last but not least, while we're looking at the regulation landscape, we need the regulation to support this development, to create a level playing field, and to ensure an approach that is neutral to technologies and feedstock alike. This would be the basis of the operations going forward. To enable investments and long-term development, we definitely agree with Robin that chemical recycling needs to be recognized as recycling. And then I would add that to ensure a smooth uptake and transition toward this circular approach, we also need mass balancing as a tool to enable maximal use of existing assets and infrastructure, and in turn, keep the processing costs reasonable. So thank you, and happy to answer questions afterwards.
Thank you, Oti. It was very useful, and thanks for giving us an overview of your operations. For many of the issues you just raised, like mass balance definitions, we will come back later. But I was wondering, you know, because you have this collaboration kind of experience with different companies, I mean, do you see specific barriers in this domain? I mean, do you see perhaps structures already in place that are difficult to intervene? I mean, or processes, you know, maybe linked to waste incineration or other processes that have been established over the years, and that does not create optimal market conditions for you? I mean, because during the discussion what we had, you already illustrated that, of course, they have high targets, but still, if you look at the European kind of capacity, still small.
True. And I mean, it is quite clear that these collaborations and partnerships are required, because circular economy, nobody can build it by themselves. But at the same time, I'm not sure if there are really structures in place, but there's definitely quite a lot of difference, you know, the technology companies typically being relatively small startups and with limited resources, while perhaps the waste management players are large and more focused on, let's say, low risk, then, of course, there's the petrochemical players who also are quite big in scale. So building those collaborations requires quite a bit of the sensitivity for what's important for each player. How do we make it a system that serves everybody? Because otherwise it will not be a circular economy.
Thank you, Iti. We'll get back to this point during the discussion. Yeah, now we can move to the next speaker. So Adrian, maybe you turn on your camera. Okay, good. So we have with us Adrian Da Costa from ExxonMobil. So Adrian, thank you for joining us today. I know that you have several investments in place, and you have in Europe, but also in the USA, and you have also participated in joint ventures. So, you know, how do you see this landscape developing? And, you know, maybe you can tell us more details about your specific processes.
Yeah, sure. So I'll just share my screen. I've got one page just to kind of help talk through some of the key things ExxonMobil is doing. So if I start off, we produce a wide range of performance polymers. They provide a lot of benefits to society when we look at applications like the food industry, helping preserve food and reducing waste in the medical professions. Plastics are used extensively for a broad range of medical applications. And then, of course, when you come to the transport sector, plastics have been used for a long time to help reduce the weight of transport vehicles to improve fuel efficiency. So overall, really helping consumers reduce their environmental footprint. So whilst plastics provide a lot of benefit versus other materials, plastic waste really has highlighted a major concern, and ExxonMobil shares those concerns about the impact of plastic waste on the environment, and there's a need to address that. It's important to differentiate the two, where plastic waste, the issue is part of a larger issue, largely related to global waste management infrastructure. I think the United Nations highlighted there's about 3 billion people worldwide who lack access to controlled waste disposal facilities. And that's why back in 2019, ExxonMobil helped launch the Alliance to End Plastic Waste, becoming a founding member, really trying to bring together a number of large businesses and non-profit partnerships to help look at a wide range of initiatives to address plastic waste globally. And without going into all of those, I think there's been some good examples of success there where in countries like Indonesia, India, and Vietnam, we've seen new integrated waste management systems being put in place in some of the cities to help really address plastic waste. And of course, once you've got waste management infrastructure in place, mechanical recycling is a traditional form of recycling to break down plastics mechanically and then put them back into applications, creating recycled content. And when we look at our portfolio, one of the elastomers we created more recently, that helps some of our customers increase their ability to use recycled content in applications. It can provide some improvements in toughness. So on the product side, we focused on finding solutions with customers. But when we look at mechanical recycling, we certainly support that where it's applicable. We do believe that chemical recycling can be complementary to that, and largely because mechanical recycling does have some technical limitations. And where you recycle multiple times, it's difficult to maintain the mechanical structure that's needed. And that's where chemical recycling can really play a role. And I think the other speakers have highlighted it's not just one technology, that can be a range of technologies. But it highlights an important difference where you're really recycling back to feedstock. You're not providing recycled content of a particular product. And where we do that, the critical thing is you're able to produce for your customers virgin quality polymers that can go back and create circularity into applications like food contact or high performance applications that you can't do with mechanical recycling content. It'd be very challenging to meet food standards with mechanical recycling. So some of the specific projects we're working on around that, in Europe, we announced we signed an offtake and collaboration agreement with Plastic Energy, where they're building a 25,000 ton a year plant to process plastic waste next to our facility in Notre Dame de Grandchamp. And that will start up during 2023. And we believe that's got potential to further expand to 33,000 tons a year. I think the other speakers have also highlighted that even when you've got waste management infrastructure in place, the industry is going to need new supply chains to really help make more plastic waste available. I think Dr. Lee and also Oti have highlighted the issues to manage impurities. Plastic waste is not homogeneous. You can't really test it in a QA/QC type process. It's challenging to manage that. And we're working with Agilex Corporation, where we set up a joint venture to become a founding member of Cyclix in the United States, to really start to put in place some of the infrastructure the industry will need on taking plastic waste, aggregating it, and then creating the pre-processing to make that more available to recycling technologies as they grow. And specifically in that area, one of the areas where we need standardization in that space is how do you start to set the standards around what are the different types of plastic waste that are going to help identify what types of waste are going to be better going into different types of technologies. So we see that as a key part of how this industry will start to develop over time. So with Cyclyx is going to also provide feedstock for some of our own ventures in the US. And earlier this year, we did a trial at our Baytown facilities to process 1,000 tons of plastic waste using some of our own proprietary advanced recycling technology that's integrated into our Baytown facilities. And that was very successful. And we announced a little bit later in this year that we're going to build a 30,000 ton facility to process mixed plastic waste to support our production of certified circular polymers. And we expect that project to start up at the end of 2022. And we believe that provides us with a key strength in this area where plastic waste, you produce a pyrolysis oil, and it does contain a lot of impurities that need to be removed in order to put it back into, especially the steam cracking value chain, to make polymers. And leveraging the existing investments that we have in refineries and petrochemical plants are key parts to be able to remove those impurities. Things like hydroprocessing we have facilities already that are running, and trying to run segregated systems for this would be incredibly challenging and would slow the rate and pace of how we develop. So when we look at those facilities, we believe the way we're doing it, we can scale those quickly. As part of that financial investment decision, we announced that provided we get the right regulatory frameworks in place, we're looking at scaling this so that we can process up to 500,000 tons a year of plastic waste by the end of 2026. In order to do that, we will also need to have regulations that support that technology. And I think the other two speakers have highlighted that we do need regulations that recognize that technologies are at the start of their development phase. And we need to have regulation that supports all innovation. And when you have regulation, it needs to be technology neutral, and it needs to be based on science on how you make those. And we believe the way that all of these technologies today look as they're scaling, they're going to look very different in 10, 20, 30 years' time when you start to see them really becoming more efficient in how they do that. A key part of that is we need to have enabling frameworks. Putting plastic waste back into the petrochemical chain, where it's very difficult to segregate what we do as plastic waste recycling from our other conventional feedstocks, requires a mass balance attribution system. When you take plastic waste and you put it back in, you really need to have the benefit of that full attribution to support the economics of the projects. And the sites where we're doing this, we use the International Sustainability and Carbon Certification Plus scheme to provide that third-party audited certification for what we're doing. And that's a really key step to doing this, to ensure that we've got a high integrity certified chain of custody model that allows that mass balancing approach to work through the value chain. So that there's a lot more to do in this space, but I think certainly as ExxonMobil, we really see the petrochemical industry playing a really key role in the future of how we solve some of the challenges associated with plastic waste. So that's all I was covering. So thanks very much, Vasilios.
Thank you, Adrian. Yeah, many useful points, and there are already some questions in the chat room regarding the greenhouse gas implications of this process and the mass balance approach. But both of these topics, we will take them on in the discussion session. Just a quick follow-up question. I have quite a lot actually, but let's focus on one aspect. Yeah, standardization. I find this very, very interesting. Very often, standardization comes up in the circular economy related discussions in various different products. Now you mentioned the link of standardization for when it comes to the different recycled plastic recycled outputs in the market, if I understood correctly. Now I was wondering, where do you think these actions should come from? I mean, do you see room for industry kind of industrial partnerships? Do you think that any specific certification body should play a role here? Maybe the European bodies. I mean, yeah. Whether you have any more, let's say, concrete ideas of the organization? Yeah.
I think ultimately creating standards around whether it's pyrolysis or the plastic waste that will today is a waste stream, but ultimately in the future is going to become a feedstock product. And using systems like ISO to help create those standards, certainly in the European Union, organizations like CEN can help provide that standardization. Where again, in a complex industry, you want to do things efficiently, and so having industry standardization that creates transparency of what are the different waste streams, it allows you to put better regulation in place about then how you can move those plastic waste feedstocks around between member states, and have a common framework. Where I think one of the strengths of the European Union is that single market, and being able to put in place consistent rules across a very large geography and across a very large part of industry as well. So that's kind of where I think on that supply chain side, there's a huge opportunity to do this to be very efficient and effective at the same time.
Thank you, Adrian. Okay, good. So maybe we can move to the next speaker, and then yeah, we'll go back to some of these points. So we'll move to Mattia Komoto from Aquafil. Mattia, thank you for your time today. I understand that, of course, Aquafil is implementing a different type of technology that it's featuring this chemical recycle discussion. So, yeah, I mean, what are your views regarding the prospects of these technologies, but also any challenges and opportunities that you want to highlight?
Yeah, thank you very much for the introduction. I'll try to share my screen. Can you see it? Just for okay. Well, first of all, I'm here today on behalf of Giulio Bonazzi, Aquafil CEO, who unfortunately had an unexpected issue and cannot join us. So I'm going to replace him. Going to the topic of this event, as you said, Vasileios, unlike what was presented so far, Aquafil has taken a different approach to circular economy and to chemical recycling technology. First of all, Aquafil is a multinational company that operates mainly, but not only, in the nylon 6 business. Though the company was founded as a conventional nylon 6 producer that uses fossil-based raw materials, approximately 15 years ago, we started investing in renovating our business model with the ambition of decoupling our production processes from fossil-based feedstock. And in 2011, we launched what is called ECONYL regeneration system, that basically is a technology operating at commercial scale, which enables to chemically recycle a wide range of pre- and post-consumer nylon 6 waste. When I say chemical recycling, I'm referring to a depolymerization process, where the nylon 6 polymer is returned to its monomer, which is named caprolactam. The monomer is then purified and then repolymerized back to ECONYL regenerated nylon, a nylon 6 that presents the same quality, the same property, and the same performance of nylon from crude oil. And all of this is obtained through a fully traceable process where segregation of material is kept. So no allocation, no mass balance approach is used in the case of ECONYL regenerated nylon. Also, beyond technological aspects, I think that sustainability is and shall be the key driver in developing chemical recycling technology. Indeed, though the plastic industry can potentially bring on the market many recycled products, if their environmental footprint is higher than their fossil-based counterparts, we will always face an issue in terms of sustainability of products. This is why we have decided to assess our footprint and to get the environmental product certification of our ECONYL nylon, certification that, by the way, is verified and certified by an independent third party. This certification basically shows that the global warming potential associated with the production of ECONYL caprolactam is up to 90% lower than benchmark caprolactam from crude oil. And this is because our technology goes one step back in the production chain and not perhaps to the beginning of the production chain. And also, unlike someone is proposing as a way to make processes competitive from an environmental standpoint, we do not take any credits for avoiding incineration of waste that we recycle through our technology. So with these few slides, I just wanted to show you that it is possible to develop full industrial scale technologies that enable to close the loop in the material cycle in a sustainable way. But this is the result of more than 10 years of continuous investment in technology, in assets, and in solution to establish a real circular economy platform. So the message basically is that changing the way of doing business, making sustainable products that do not rely on fossil resources is not the result of an overnight work, but it takes time. And unfortunately, I have to say that we see almost every day creative shortcuts that allow companies to claim as sustainable and circular those products that in reality are made from crude oil. These initiatives, from our standpoint, should be clearly regulated in order to avoid any misuse of them, since they could damage the credibility and the commitment of that share of the recycling industry, which in the last 20 years has invested in real processes and technologies to deliver real recycled products. This is basically all from my side, and thank you again for the opportunity of speaking today, and of course I'm available for any question.
Thank you, Mattia, for presenting details about your process, and definitely we take a good note of your, let's say, criticism over other chemical recycling process and the mass balance approach, which we will have dedicated discussion on this after all the presentations. But yeah, I mean, perhaps it would be useful for the audience just to maybe give a little bit more information regarding the waste streams you currently manage, and that you think you will be able to manage in the coming years, perhaps with technological innovations. Because one of the starting messages, let's say, in this event is that there is a very wide range of different waste streams, and some of the existing technologies can only be applied to some certain waste streams. So for us to have a good mapping, maybe you can just give an overview of where do you stand now, or even where do you think you could start in the future, and then we come back later in the discussion session regarding mass balance and the other issues. Yeah.
Well, definitely the nature of the waste that can be processed to our technology is probably the most challenging part. Today, we recycle both pre- and post-consumer waste. Among the pre-consumer, we are talking about textile scraps, plastic scraps, and byproducts or waste from the nylon 6 production. While in the case of post-consumer waste, we are mainly talking about old carpets and aquaculture and fishing nets. We collect those waste basically from all over the world, and we bring them to our facilities in Slovenia, where our ECONYL regeneration system is located. Of course, we are still investing in developing new technologies that could perhaps one day enable us to recycle streams of waste that currently cannot be fed into our system. The reason is very simple. Nylon 6 products are basically not made of 100% nylon 6. but nylon 6 represents just an ingredient among many others used in the product formulation. So we have and we had developed different technologies that enable to separate the nylon 6 fraction from all the other ingredients and deliver the nylon 6 fraction to the chemical recycling step. And the beauty is that those technologies do not rely on any organic solvents, so they are quite, let me say, environmentally friendly.
Thank you, Mattia. And you might note there are a couple of technical questions for you in the chat box towards the end. Maybe you try to answer them while we have the last presentation. So thank you very much. We'll get back to this point. So we move to Yannick from Zero Waste Europe. Yannick, you always have the privilege of being the last one in this row of let's say, presentations. And, you know, I know you follow the debate very closely. I don't know if you feel more insightful after the 4 previous presentations, but yeah, we look forward to your perspectives, and I'm sure you will have a lot to say later in the debate as well.
Can you see the right slides? Yeah. Okay. Yeah. It's all okay. Can you see the?
Okay.
Yeah. Okay.
So let me go full screen. If you can go full screen.
Okay. I think okay. Sorry. Yeah. It's always the case. Yes. No problem. Yeah. I think it's the problem is, as always, sharing. Just a second. Well, sorry. It's showing the wrong one. Yeah. Okay. Just a second. So I have to. Okay, no. Okay. I think I have a problem here now. Stop sharing. Okay. Okay. Good. So sorry for this. I'm using 2 screens and it was not showing what I wanted to show you. So let me make it. So first of all, thank you, Vasilios, for inviting me again to speak, and particularly from the looking at the things from the how the things are globally. I must say that our focus at Zero Waste Europe is mainly on policy, but of course I'm very happy to comment on what is happening globally, because we are also following it in Brussels. I would like to start with this slide here. Maybe a bit shocking slide. So because I think it's also always important to look at things from the in the context, because things don't happen in vacuum. And so the reality is that the current plastics life cycle is actually is not very sustainable. So it's clear that if we're going to continue doing what we are doing now in terms of manufacturing plastics and end of life treatment of plastics, then we're going to eat up the whole carbon budget available for the 1.5 degree scenario. So what is clear is that action is needed. And then the question is, of course, how we're going to get there. I think what is particularly important is to look at what is happening in terms of now. The end of life treatment is a clear example of what is wrong with when it comes to plastics. We can see currently that a lot of plastics is incinerated and very little is recycled. We are seeing a total divergence from emissions from end of life treatment of plastics. You can see the red line here represents the emissions from incineration. They are going up, while the total EU emissions are going down and hopefully reaching 0 in 2050, or hopefully even much earlier than that. So what is clear is that we need to change that. And then the question is, of course, how we're going to get there and where the chemical reprocessing could play a role. And here I wanted to share an image in terms of like what is the important, how we can get there, and particularly how to keep the value of plastic as long as possible, but also in a more carbon efficient or low carbon or way, because that's important, because we are living in a climate emergency, and then we also need to consider that. So here in this image, you can see we have, starting from the right side, we have sort of use, reuse. So this is actually the friendliest option for dealing with plastics. This is something that we used to do, maybe 30 years ago, 40 years ago. And now it has had a diminished role, but we have to rethink our ways, and we have to get back to reuse, because this is simply the best option in terms of climate and also pollution. And then we, of course, we go to other options. Some substitutions probably is needed, but then we come to recycling, and the friendliest options, they are currently mechanical, and then the further down to we go to other types of recycling, and even I would say recovery when it comes to a molecular level management of treatment of plastic waste. And why is that important? Because this is not only these are not only different types of cycles, but they're also cycles in terms of they represent also the related carbon emissions, because those processes are they get more and more energy intensive the further we go from the right side towards the left, and also the complexity of these processes is getting further and further complicated. So yeah, and that has to be considered and taken into account when we consider what is happening now in terms of how the global developments on recycling and chemical recycling particularly. So I just want to say that we, Robin mentioned that we have a lot of developments around pyrolysis, and the question is that the most efficient way, and is that a way to in a future, and taking into account also the need to really cut down on our carbon emissions. And I can just say that we have done a review of some of the LCAs, the most commonly cited LCAs available. So that was, I think it was 1 year ago. So here I can just show you that we have looked at, for example, the BSF LCA, where it's quite clear that if you look at the kind of light blue emission from the pyrolysis processes, and then if you compare to the production of virgin plastics, then the emissions actually are higher. So the question is, of course, it raises immediately, is that can we actually afford moving in that direction? Since we need to, even with the business as usual, we need to cut down on our emissions if we want to keep to 1.5 degrees scenario. And it seems like the technologies which were at the very left end of the image I just showed you tend to be very, very, very energy intensive, and therefore releasing quite a lot of greenhouse gases. So yeah, and what we are proposing, by taking into account the related carbon emissions, but also some the recovery rates of the actual materials that come out of these processes, we recommend to have some prioritization. So putting the most environmentally friendly options at the very top, such as mechanical and dissolution recycling, and then put as a second would come polymer to monomer recycling, and so called depolymerization options, and then define polymer to molecular technologies as a recovery. And at the moment, unfortunately, of course, there is a lack of clarity in this sense if how they will be regulated. But I think this would be needed. And when it comes to, just wanted to clarify, when it comes to the distinction between the first layer, which is the mechanical dissolution recycling, then and polymer to monomer recycling, then it's not enough to regulate them via waste hierarchy, because waste hierarchy, we have had it for more than a decade, and it has not really pushed us towards waste prevention. So there is also need to have some safeguards in place to ensure that the first option will be always mechanical and dissolution recycling. Therefore, we recommend also that only when we do the sorting for plastics waste, then only the rejects would go to those RL levels of treatments. And I also think it's important because we talk a lot about different feedstocks, sort of like treatment options, and the fact that some of the technologies can deal with maybe mixed plastics, but we also reality is that we know that they have a lot of challenges. Robin just mentioned a couple of them. And therefore, it's also important that we focus very much on upstream innovation rather than try to come up with high carbon solutions to deal with plastics, and particularly hard to recycle plastics, single-use plastics, which should be faced in the first place. So I think it's also important in this discussion to focus on really improving the actual recyclability of plastics, which is the main issue. It's not so much about to come up with technology which can solve that, maybe at the molecular level. We should focus on the upstream and then start phasing out hard to recycle plastic as soon as possible. And I know that at least here in Europe, the European Commission is working on that. And the chemical recovery, which is very energy intensive, should always come as the last resort. So yeah. And I just wanted to mention a couple of things in terms of what is missing in terms of regulating chemical recycling, chemical recovery, both at the EU but also on the global level. I think there is still missing the definitions, what they are, and which one of them are chemical recycling, which one of them should be recovery. And also more importantly, I think there is a lot of confusion when we talk to our colleagues in the US, but also in other parts of the world, is the fact that some cases recycling is considered as a fuel production. I think this should be sorted out and should clearly exclude any fuel production. It's also important to have a very ambitious standards for determining the actual recycled content in order to avoid greenwashing, because we see now products coming out claiming to have 100% recycling. And we know that if you would really follow up on them, you would maybe find no recycled content at all, or you would find maybe that only 2% or 5% would come from recycled content. And this is all because of some of the private standardization verification systems that allow free allocation and even trading of recycled content claims. It's also important, and I think Robin mentioned, to have also methodology for comparing the different life cycle assessments, because at the moment it's extremely flexible, and honestly LCAs are not really comparable. So it's very important that we have some kind of reference in that. And I think it's important that we, particularly the public funds, they give a signal towards options that are more lower carbon, and particularly, and in here, I think we have to draw the line. If something produces more carbon than production of virgin feedstock, then it should not be supported, simply because we cannot afford it. And finally, just wanted to say that we also need to have a framework to encourage doing the right thing. And I want to mention one of the things that we can do is to have a carbon pricing on waste incineration in order to encourage sorting and recycling. And I think that should be done everywhere. So yeah, I'll stop here, and I would be very happy to have a discussion with the panelists and participants. So thank you.
Thank you, Yannick. I mean, maybe I can ask all the panelists to turn on their cameras as well. Good. Okay, we just miss Robin. Okay, very good. So Yannick, I start with you. Okay, first of all, in your presentation, but also in Ron Bean's presentation, you opened the Pandora box of the waste hierarchy. Okay, and just to remind, of course, of the first principles of the waste hierarchy were introduced in the fourth Environment Action Program in 1989. So obviously quite a lot of things have changed since then when new knowledge is coming in, but also inherently chemical recycling is more complex than other kind of products, because in other products you can claim that the product that enters a recycling operation, then that's the recycling stage, but it's much more complex than chemical recycling. Now, I could notice there were some differences in your slide, in your two slides regarding what should be considered recycling. But if you can go back to the basics, I mean, what do you think, Yannick, could be the criteria for determining what is recycling or not? I mean, would it be that if, let's say, the recycling output is used in a new product, but then of course that might be very challenging to determine in some cases, as we have heard from a technical point of view, or whether you think there should be other criteria, because there will be inevitably at some point discussions in the revision of future waste framework of the waste framework directive. And now, I would also welcome any views from your side on mass balance, because we heard a lot. Maybe also kick off this part of the discussion as well. And yeah, I mean, whether you are in favor of such a system or not, or under what conditions you think that such a system could function.
Yeah. Well, thank you. So when it comes to our views, I think it's quite easy when we look at all the technologies. Then something that is not ending up as a polymer should not be considered as recycling. So when you look, for example, look at the pyrolysis processes, pyrolysis does not produce output that is recyclable. It's really a kind of preliminary step in a very long chain. So it needs to be normally purified, fed into a refinery where it's refined with a virgin feedstock and then cracking and so on. So I think it's actually really not recycling in my opinion. And yeah, so I think that's quite clear. And then it comes to so it's a bit similar for the gasification.
So Yannick, just to make it clear, you think in your view any product coming out of pyrolysis should not be considered as recycling?
Yeah, because pyrolysis output is not really polymer. It's very far from the process. So it's a kind of a pre-treatment process, really. It's the first step to remove, to turn it into oil. And this oil needs to be improved, cleaned up, and then fed into the refinery. Yeah, and then if I may, you also asked about the mass balance issue. So when I think we are very worried about the greenwashing, because we see that there are claims to have a recycled content. I think we have to be very careful. Any kind of method to allocate recycled content to a product needs to be really based on traceability, on physical and chemical traceability, and it should not be just freely allocated. And otherwise, we will start having products that have no recycled content, and if you go in a supermarket, you will see them all the having labels such as 100% or, and I don't think it's helpful. It doesn't help. It's cheating consumers, and it doesn't also help with phasing out of the products that are currently unrecyclable or very hard to recycle, really.
Okay, thank you, Yannick. Yeah, maybe I move to Robin, and I saw you were very busy responding to some of the questions in the chat. But yeah, I mean, I think you already alluded to this in your presentation, but any further thoughts on waste here? I'm not sure how deep you are in the legislative discussions, but I'm sure you have some thoughts on what should be, at least from a technical point of view, considered as recycling or not. I also see a comment in the chat box that that maybe should consider pyrolysis by large cross. Pyrolysis can be considered as a recovery operation to prepare for recycling. Yeah, I'm not sure, what could be, whether this could have a legal standing, but yeah, your thoughts on it. And I don't know, again, if you're deep on mass balance, but I'm sure you have some thoughts on, because you are close to market commercialization, so I'm sure you heard at least of these issues, yeah.
Right. Actually, this gels really much with what you asked me immediately following my presentation, right, about the whole definition issue. I think right now it's just very unclear what is chemical recycling and whether it is even chemical recycling. Let's consider the alternatives. Right now, we know that based on feedback also from the mechanical recyclers, they are hitting their limits in terms of what they can recycle, because products on the market are getting more complex. We are getting a lot of composites. We are getting also challenging materials, which are with carbon fiber, glass fiber, etc. So this kind of materials, if we do not open an option for them, what's the alternative? I mean, it's really a question I would just like to throw out there to everybody. If it's not mechanically recyclable, and mechanical recycling is, of course, right now the ideal route because it's less energy intensive. If it's possible and can be channeled easily into the value chain, it makes sense, right? We are out here to find a way which could contribute to decarbonization, circularity, etc. So it has to make sense. But what's not mechanically recyclable right now on the market, it goes into incineration. So the question is, what do we do with this? If we do not say that we want to open an opportunity for another set of technologies to try to bring this back into the cycle, does that mean we just end up burning everything? I mean, it's just an open question out there to the floor. And then with regards to what Yannick is saying, that if it doesn't end up as a polymer again, we do not think that it's recycling. I don't really agree with that, but I think we agree to disagree on that already with Yannick. The thing is, anytime, I mean, it's if you're burning something, it's always easy. It's just putting on a big fire and throw everything in. If you want to make product something valuable out of waste, we have to consider that waste is at the end of the lifespan. These things are contaminated, they are dirty. I fully agree with the push in the AU. We go for more eco design, we go for a higher separability and increase the mechanical recyclability. But the thing is, that's going to be things out there where this is not possible. So in those kind of scenario, chemical recycling could play a role. We are not saying that chemical recycling should be, and again, it comes to the part, is this recycling or recovery? As I just said, see the comment from Lars. Maybe you can put it as recovery before recycling. Okay, if you speak to an engineer from a technical point of view, if I'm breaking things down and into its components as a monomer or into molecular basis before going into product, the question is how this is used later on, because we are talking about an integrated process. The route where it goes in is a long process. It's not a direct route to say that I have a magic box and suddenly a polymer will come out. It fits into a process, whether a steam cracker in the case of a pyrolysis oil, or in the case of gasification, syngas, it goes into the synthesis process. It's just that we are complementing and maybe slowly doing a substitution of current fossil feedstock. So there's actually two impacts here. Maybe doing an option for waste, which is currently being incinerated, and helping at the same time to substitute some fossil fuel. Maybe we think about it in this case, it could bring another aspect into the whole discussion.
Okay, thank you, Robin. And maybe I can move now to Oti. And yeah, you heard about the different perspectives on. I think you made clear that the products that you make, you think they could fit on recycle, but maybe you have some further thoughts on this and on mass balance. Now there were a couple of questions on mass balance. I think that one participant asked that the speakers could provide an overview of mass balance methodologies and specifically on free allocation method versus the restricted allocation for recycled content certification. I think this is linked to the current policy discussions about how this system could be put in place. And also Jane Wabel here, I hear that she's mentioned that the mass balance is an approach widely used by the plastic recycling industry. The physical traceability of waste is a requirement under certification bodies and standards. How will pyrolysis and gasification plants ensure with physical traceability of plastics from waste to recycled pellets? Well, I guess maybe this is technically difficult, but yeah, I thought to bring some perspectives from participants as well. So, Oti, the floor is yours.
Thank you. There was quite a lot to decipher there, so not able to cover all of it probably. But to address, I mean, first of all, the question of how do we classify, and the question is, what do we really aim for here? And I think Robin put it quite well. If our target is to maximize plastic recycling, and even if we would aim to maximize mechanical recycling, even if we would go for maximal reuse and maximal eco-design, there are still going to be plastics that are too contaminated, too mixed. There will be multi-layer packaging or multi-material that just cannot go through mechanical recycling. And even if we would say that we prefer some of the other technologies, like let's say dissolution, depolymerization, it is quite clear that they can also handle only a short or a limited amount of plastics. So depolymerization technologies are not fit to process some of the plastics. So is it more important to be idealistic and to block utilization of plastic waste, or do we actually want to maximize the use and utilization of plastic waste, bring it back to the circular economy, even if we would be paying the cost of, let's say, lower energy efficiency in order to achieve that higher feedstock flexibility. So that's one thing. On the mass balance topic, so as I said during my part, I think this is something that is definitely needed for transition. And I mean, if we want to incentivize and to encourage implementing these technologies, one of the first things to do when we're looking at plastics making or oil refining, these are huge assets. So if we require that the processing should be in a segregated way, and I mean, it might work for certain polymers as for aquafill for the nylon. But the truth is that the waste plastic out there that's collected post-consumer is of mixed nature. So do we want to make it really difficult to implement and to require high capex investments into segregated processing, or do we allow to use the existing infrastructure, the existing assets, and just because of the scale, it's absolute necessity that we use mass balancing?
Okay. Thank you, Oti. Can we move to Adrian? I mean, you can pick up any of these points.
Yeah, I'll try not to kind of go over the same points, but I think it makes some good points, and it comes back to what I said earlier. I think when you look at the scale of the plastics industry, the amount of waste that is generated, this is a large-scale commodity business, and so there will be a need for all technologies to be deployed where they can be effectively, whether that's a small scale, but in order to deal with the much bigger challenges of the larger volumes of waste, you do need technologies that will scale and fit with the scale of feedstocks that are being produced in the petrochemical industry today. And when you look at mechanical recycling, again, I would agree with all the points about why mechanical recycling is important. It's going to have the lowest greenhouse gas emissions relative to today, but it does have limitations. And the way that limitation is managed today is mechanical recycle is often blended with virgin polymer. It needs a rejuvenation step to allow that mechanical recycling chain to work on a semi-continuous basis. And chemical recycling, I agree, it's not providing content in the same physical way as mechanical recycling, but it is taking the same waste back to a building block to allow you to go back and build polymers again in the same way you've done it. And chemical recycling could really play a complementary part in that overall rejuvenation step needed in mechanical recycling when you look at a system overall. And I think that the overall challenge of, look, there's a lot of plastic waste today. The majority of plastic waste in Europe is incineration and landfill. And you need something different to do that, and you need to deploy things that are at scale. So I think that's, for me, a kind of a key thing, that we anchor on trying to measure everything in the same way that we measure mechanical recycling and content today. But at the same time, we're introducing a new concept of circularity. And circularity is not about creating content. If we look at a kind of a hypothetical facility that's producing 1 million tons of plastic and then you take back 1 million tons of plastic waste into the same system, what you're actually doing is you're replacing what that conventional feedstock was. You're replacing it with waste. You're not producing more fuels, you're just replacing that. And with a mass balance system, the reason why you need to have that full mass balance attribution is because you have to go through steps to get the molecules to be able to go through the same systems. And it is complex where they interact, and based on economics, you can put feedstocks into steam crackers based on economics, where when you don't take them, they do end up in fuels. And that's an economic choice, which is why it's very difficult to decouple it. And it's why you need a principle of mass balance to do that. But if you apply a fuel exemption, then all you're doing is you're saying, well, even though you took back all of the plastic waste you've generated, with a fuel exemption, you would then end up saying you only get, let's just say, less than 50% circularity, even though there's nothing more you can do based on the plastic you produce to increase that number. So when you look at the benefit to society, it's really in processing the plastic waste back into the systems that produce the plastic. And when we start getting into how we're going to measure that, that really comes down to how much of what you take in as waste are you going to allow to be attributed back to certified circular polymers. And I don't like the free attribution terminology. It's a full attribution back to the products that basically made the predominant part of that waste. And when you take a fuel exemption, all you're doing is you're saying you're going to create less certified polymer, which is going to make that more expensive. And there's nothing more you can do to process more waste once you've taken everything. So it comes down to a principle, I think, that I do agree. Making circular polymers through a chemical recycling process, it is different to mechanical recycling. You're not physically creating recycled content, but at the same time, it should be compared the same, and it should be contributing to recycle rates and recycle targets, because it is a key part of dealing with the plastic waste and reusing those materials. So I think that's one element. That's why the mass balance is critically important to that. And it's very difficult to do anything different to a mass balance system in this setup. And it's used in a number of other industries very successfully to manage the complexity where you have these integrated systems.
Okay, thank you, Adrian. Maybe we'll move to Mattia. I don't know if you want to comment on any of the previous perspectives, but yeah, where some of the points raised was that some of the existing waste streams cannot basically be used through all the range of technology. So in some cases, you might need to have some processes in place for these waste streams, and maybe you need to find a way to allocate recycled content. So I don't know if you have any views on this, on waste streams that particularly you cannot deal with this right now with your current technology, but also more in general. I mean, would you consider the system of certification as inadequate or insufficient, because certification is used in various areas of European environmental policy? I mean, or do you think that perhaps a more rigid approach is needed, or perhaps complete separation of technologies on the way they're treated under the system? Yeah, any thoughts in all of these issues, Mattia?
Well, I mean, I agree with the concept that, of course, one of the topics we should invest on is eco-design to make more recyclable product from the beginning. But of course, at the same time, there are already on the market products that were not designed to be recycled at the end of their life, and somehow we have to deal with. I do not have anything basically against pyrolysis or gasification if this technology avoid products to go to end up in landfill. And I do not have basically nothing against feeding large-scale infrastructure that are already existing with the alternative feedstock that perhaps is the pyrolysis oil. I mean, nothing against this. I think the issue comes when the allocation concept step in. And I think it is completely decoupled and completely independent from feeding large-scale infrastructure with a share of alternative feedstock. Because basically, if anyone feeds 1% of alternative feedstock in an already existing infrastructure and freely allocate 100% content of a given product based on what that person wants that day, what should be the incentives of moving from 1% of this alternative feedstock to 5, 10, 20, 50%? If you already get everything, if you already have the possibility of labeling a product that perhaps has 0 recycled content, and you can label it as 100% content, what is the incentive of increasing the share of alternative feedstock that you can feed into your existing system? From my point of view, I mean, there is no incentive. You already have everything. So that's why, in my opinion, technology is not an issue. Technology is fine. Is the accounting methodology of the free allocation that is an issue and represent an issue for the recycling industry.
Mm. Okay, thank you, Mattia. And we take a good note of your concerns regarding the level playing field and what would be the risks, let's say, if companies would be able to allocate, let's say, recycled content freely to products. I mean, maybe we can hear later views from this from Adrian and Oti. Yeah, I mean, I move now to Yannick again, which I'm sure you might have some points to pick up. But yeah, I mean, maybe Yannick, we can also touch a little bit the issue of greenhouse gas emissions linked to all of these different processes, and never-ending discussion. I remember in July there were quite different views and perspectives. And I know you are of course, you are not a technical expert on this, but you are following different life cycle assessments. Now I saw a comment from PepsiCo that basically this question specifically on pyrolysis and greenhouse gas associated emissions. We note from publicly available life cycle assessment studies that there is significant credit that is attributed on account of avoided incineration credits. I want to get an expert view on the current level of technology and maturity, realistically, how much of waste feedstock for pyrolysis is expected not to be mechanically recyclable. These are also issues that Robin can pick up later, because I know you're working on some categorization of LCA technologies. But Yannick, to wrap it up, yeah, there are a lot of studies, but where would you think we stand in terms of evidence? And here I'm not speaking only necessarily in terms of comparing these processes with incineration, but also with virgin plastic production or with mechanical recycling. I mean, is the evidence there? I know the LCA is always a never-ending discussion in the policy debate, but yeah, any views on this or any other topics raised today?
Well, yeah, well, thank you. Yeah, I'm not sure. So I understood the question is mainly about what we know about the LCAs and the greenhouse gas emissions from different technologies.
Or whether you see any important gaps at the moment, because I know you a lot of different studies.
Well, I mean, I'm there are gaps all over. It's I know that you know, there are many studies happening at the moment, and one of the main issues is that the technology providers don't give enough data. So, for example, we know that Joint Research Center is working on a study to look into what is the best option for treating different types of plastics, and they don't get enough data, and there are many other ongoing studies. So the gaps on studies on the LCAs is huge. And what we see is also, and particularly when it comes to not only to greenhouse gas emissions, but there are even less data available on, for example, the toxicity of the outputs, residues, how to deal with them, and so on. So there are huge gaps, and we are talking now. I've been following chemical recycling, I think, since it started the discussions here in Brussels. It's about 2 years ago now, and the main issue is that, you know, there are a lot of information out there saying that these technologies are like sort of like, you know, you can circular economy 100%. But then the more I follow, the more I see that there are challenges, and there are a lot of challenges, and the focus is really on basically on one of the technologies, which is the pyrolysis, and it's a convenience. It's really convenience also in a way, because it really relies on existing infrastructure. There's no improvement in that. it's very greenhouse gas intensive. So as I said, we have reviewed the most widely cited ones, and we see that they do not help to mitigate climate change. They might help to deal currently with instead of burning, but we need to move away from that. We need to move away from burning. We need to move towards low carbon ways of managing our waste. And so I think that's my my opinion on this.
Okay, thank you, Yannick. And yeah, I mean, Robin, you might have some views on this. Now, I also saw a question from Gian Pietro from European Commission DG RTD that whether chemical recycling is reduced to recycling of plastics, and whether there are other areas where chemical processes are key for recycling of limited raw materials and chemical feedstock, and where return economic case should be treated. Yeah, I've also seen personally a lot of different waste streams in the literature, hazardous waste, even ocean waste, agricultural waste that could be potentially fit for chemical recycling processes. So not only plastic, but I was wondering, what is the gap between, let's say, evidence in the laboratory scale and commercialization? So any of these 2 points, life cycle emissions, which I know you're very deep on it, and the potential for other streams. And, I don't know if there will be time for other comments, or if you want.
Yeah, maybe just a quick comment with regards to life cycle. I agree with Yannick. That's definitely a lot of gaps right now on the studies which been reported. From our side, maybe because we are closer to the technology developers on this side, we understand that to a certain extent, information cannot be made completely transparent because it's proprietary. We are also talking about competitive edge here against their competitors and other providers on the market. And it's something like copyright, right? In a certain sense, if they release too much information, then people will know what they're doing. But we agree that there is a need for of some sort of basis so that the public and the policymakers can comparatively evaluate the technology. And that's why we are currently working on the project right now to develop recommendations for LCE guidelines and also for TEA guidelines to like a checklist form. Have you carried out this sort of calculations? Have you considered this aspect? Have you considered integration or byproducts and all that? So that at least from the decision maker side, when they look at the LCA study like that, they know that this aspect has either been considered or left out, or to what extent. That's probably our more of a intermediate approach rather than complete transparency, which I think no technology developer on the market will be able to do, compared to complete secrecy, which doesn't help decision making. So that's the comment on the LCA side. With regards to the other aspect, Vasilis, if you could just remind, I got so caught up in the LCA, I forgot the second one.
No problem. On the possibility of using other waste streams beyond plastic, and whether there are other areas where chemical processes have potential, and how far are we from commercialization of such processes?
If we are looking at other waste streams, I would say that then I'm very familiar with gasification developments, especially because we are working on that ourselves. But in Germany, I just like to share an example from Germany from the 1990s. Waste gasification is not something new. In the 1990s, Germany started already in Schwarzepumpe and Beerenrad pioneering activities during that time, looking at gasification of multiple waste streams, not just plastic. They were looking at municipal solid waste. They were looking at contaminated wood. They were looking at sewage sludge. They were looking at all sorts of different ways and testing them in industrial facilities. But at that time, they were using 50% coal and 50% waste. And in Schwarzepumpe, towards the end, up to 75% waste with coal as a coal feedstock. The reason why coal was in the mix is because the gasification development came very strongly from coal gasification. So that was that basis, right, in that time. And we know that 100% waste gasification today is possible as well. There's a lot of development on hazardous waste gasification. And we have heard of test campaigns from different technology developers with shredder materials. We are looking at biomass in the sense of agricultural waste, straw pellets. We are looking at also husbandry waste. So there's a lot of developments in this direction. And what I've noticed today, also from the Q&A that I've been going through, is that the focus is very much on plastic to plastic. And chemical recycling is so much more than plastic to plastic. And it seems like the technology development has already moved in this direction, but the policy-related discussion is still very fixated on plastic to plastic. And I hope that somehow maybe in the near future, this discussion will open up because chemical recycling has a role beyond plastic and could contribute to really circularity of carbonaceous waste. And that's just not only plastic.
Thank you, Ropin, for your contributions today. Yeah, I move to Oti now, which I'm sure she will have something to say on the greenhouse gas emissions performance of the technology. You know, obviously we don't expect to reveal any internal assessments, but I think this is an area where more evidence is needed, let's say. So you may have some views on this. Now we also received there was also a comment by Stefan Arditi from the European Environmental Bureau, who was not convinced regarding what he heard regarding the hazardous impurities and the potential for this technology in dealing with the hazardous impurities in these products. I don't know if you, Oti, or Adrian, or Mattia have something to say on hazardous substances and how this can be dealt or are dealt at the moment with the current technologies. So yeah, any of these points raised or any other remark you would like to make towards the end of this event?
Yeah, well, I think the transparency and the requirement for data, that's definitely out there. And I do agree with Yannick that there's quite a bit of misinformation out there. And yet again, I'm afraid to say that some of that misinformation is related to the greenhouse gas emissions of some of these processes. But definitely it would help if we had a joint way of measuring, and basically to have a methodology in place and have whether it's recommendations or whether it's already a full LCA methodology, how should the environmental benefits of these technologies be measured. I think the challenge there might be that this is indeed a family of technologies, and they can differ quite a lot in what is actually the value chain, and thus we might need separate methodologies. So we are again comparing apples to oranges. But you know, even within a certain technology family, we have seen some studies published already. Unfortunately, those studies are quite heavily being challenged and attacked. So rather than, you know, the public being happy that at least somebody is pioneering, this is not perhaps encouraging to the companies when they need to respond to these challenges. And I'm with Ropin on like there needs to be a certain sort of a respectful level of how much proprietary information is actually required to be revealed, and how much transparency can we expect from technology developers for whom this is really bread and butter and their most deepest secrets. But yes, it would definitely help, and obviously in the regulation and decision making as well, if we had comparable data and we were able to really measure what are the benefits and how does chemical recycling compare A, to incineration, but then also B, to virgin plastics manufacturing.
Thank you, Oti, and for your contribution today and for your time. Adrian, which point would you like to pick up? We heard about the transparency, greenhouse gas emissions, different views on these things, but yeah, the floor is all.
Okay, thank you. Maybe I'll start on the kind of LCA, and it's not an exact science, but what comes out of it is a precise number. So it's often you have to have the detail behind it. I mean, what I can share, and Ropin said it very well, and so is Oti, about the proprietary nature doesn't always allow you to disclose what you want to do. And that's a little bit the situation we're in at the moment. But we have done the assessment of what we're doing in Baytown, and we have done it to one of the ISO standards. It is out with third-party verification and checks on that at the moment. But we haven't shared that yet. But what I would say though is, I think Yannick did a very good analysis. So I think when you look at that, you go, what is one of the big gaps that you have on standalone is some of the molecules you're using as fuel. When you integrate, you can upgrade those molecules back to where they should go. And I would say refineries and petrochemical plants, they're designed to basically take in raw materials like crude oil and put the molecules in the right places. And when you do that, you get a much higher yield from what you're doing, maybe today on some of the analysis that's out there. And the analysis that we've done, and looking at different scenarios, so I would say we take more of a conservative approach of how we assess that. We would say that if we look at the plastic waste coming into what we're doing, and then we compare that to the liquid feedstocks that it's making that go behind petrochemicals, we would say that has a lower greenhouse emission than you would do running a conventional feedstock. And that's really drawing the box around making the feedstock that then would go, and then it's identical to go into the petrochemical chain. So I come back to what I said at the start is, as technologies develop, they will scale and they will get more efficient. And it's important not to anchor too much on something today when the technology may look something different in the future. And so I do believe that pyrolysis will address some of the energy intensity gaps. And certainly when you get into integrated into facilities, we will see this is not just a discussion then also about the circularity of plastics, the kind of pathways to net zero emissions as well will bring in technologies that reduce energy intensity. So those gaps will come down over time as well between technologies as industry reduces its energy intensity as well. So I think I would say people should be open-minded to what the opportunities are, rather than looking at what is the limitations of a technology as it's first deployed when it's not being scaled to the level that it could be. And then I think the question on impurities is it comes down to the fundamentals of, you get a lot of those same impurities when you're processing crude oil, a lot of the trace metals, and refineries put molecules in the right place, but the large part of the big conversion units and the big hydroprocessing units and the cleanup steps are there to remove those molecules from those streams and create pure streams that can be used in petrochemical feedstocks, can be used in other applications, and to go into the fuel pool as well. So I think the how you clean up the impurities, I would say, a raw pyrolysis oil by itself, that's a pretty difficult feedstock just to run without thinking about how you're going to manage those impurities.
Thank you, Adrian. We'll close with Mattia. So Mattia, any views on greenhouse gas emissions and transparency? And any insights on how your technology performs in this domain? Now I know that, please prove me if I'm wrong, from what I read, that there is no mechanical recycling of fishing nets and carpets that you are currently using. So basically it's not easy to compare your technology with another mechanical recycling technology. But any insights on carbon reduction performance, transparency, and any kind of element that you would like to pick up?
I mean, the LCA and of course the footprint of the technology is a powerful tool. As said during the speech, sustainability should be the key driver once selecting or once developing a new technology, a new recycling technology or a new bio-based technology. If the ambition is to move to a more sustainable plastics economy, definitely we should use a tool like the LCA to compare what is the current status versus what could be the scenario by adopting innovative technology. And of course, even in the case of this innovative technology have a higher footprint compared to the conventional process, I think we are not moving to something more sustainable. So definitely a higher effort in making innovative technology really sustainable and more sustainable than conventional process is required by the old industry. But definitely we need rules. We need rules to compare also between as you said, it is complicated to compare a mechanical recycling technology with a chemical recycling technology. But at the moment, there are no clear rule on comparing also between two different chemical recycling technologies. So again, if the ambition and the direction is to go towards a more sustainable plastics economy, we definitely need a clear rule to assess the sustainability of each technology.
Thank you, Mattia. I would like to really thank all 5 of you for your time today. I know it was long. Actually, we have a lot of people that stayed until the end, both in Zoom and YouTube, which shows that there was significant interest. And also the topic is, it attracts attention, let's put it in that way. I think we had I'm pleased that we managed to get all of these different perspectives on the table. It was not easy. So yeah, I would like to thank all of you, also the participants, for your time. There will be more discussions next year, of course, in the context of new regulatory developments. And yeah, happy to stay in touch and to have further similar debates in the future. Thank you.
Thank you.
Thank you.
Thank you. Bye.
Thank you.
Thank you. Bye-bye.